Hello everybody and welcome. In this video we are going to name these following coordination compounds. Now if you haven't watched my video on the introduction and some rules of naming the coordination compounds, make sure you do that. I will drop the link in the description button below, so make sure you click and watch the video to have proper understanding before we get into these namings. Now let's start with the first one. The first one is CrCl2H2O4Cl. So this is an ionic compound, okay, an ionic coordination compound. So what you have to do here is to separate them the way we do. So we have Cl, Cl2, H2O4 and Cl. So Cl we have negative and this we have positive. Now you name the positive end first before you name the negatives. Now to name this itself, it's a cationic complex. So you have to name the ligand first before you name the metal. So the ligand here are water and chlorine. So water will be aqua. So the name of this water will be aqua. So aqua, and we have Cl, which is just chloro. Okay, so we're having two things here. So the A comes first before chlorine. So we name the water first before chlorine. And we have 4 of that. So that will be tetra aqua. Then we have 2 of chlorine, dichloro. Then name your metal. Your metal here is chromium. Now I told you, before anytime you are naming your metal, you have to put their oxidation state. So you calculate the oxidation state and you put it, then you name chloride. Now how will you calculate the oxidation state? So let's say oxidation states of this plus that of this will give us +1. So we don't know for this, let's represent it with x. For chlorine it will be -1. So and we have 2 of that, so that will be -1 times 2, then plus water is neutral, so 0 times 4 must give us +1. So that will be x minus 2 equal 1. So x will be equal to 1 plus 2. That will be 3. So you put chromium 3 here, and that's your name. So the name for the first compound is called tetra aqua dichlorochromium 3 chloride. Now for the next example, we have this. Now to name it, so we have named this, we are now on this second one. So now to name this, it's still the same thing. We're having chlorine here, so you just have to put 2Cl minus, and the other one will be positive like that. So we're now having CONH3 5ONO2 plus. Now to name this compound, you have to name the positive end before the negative end. So as it is, this ONO is a ligand. Normally we represent it with NO2 minus. But there are some ligands that we call the Ambidentate ligand. They are the ligands that can bind with metal with 2 different atoms, but they will use one at a time. For instance, this NO2 now, it can bind with metal with its oxygen or with its nitrogen. Okay, so when it's bind with metal with its oxygen, normally the name of this will be nitrito. That's what they call it, nitrito. In coordination compound, it is nitrito. But if it is bonding with its oxygen, we call it O-nitrito. And if it is nitrogen, it will be N-nitrito. So we have another compound where it is bonding with oxygen, and we have a compound too in this example that is bonding with nitrogen. So in this case, since you have O first, it means that it is bonding with what? With the oxygen. When you just have normal, say for instance you have NO2, when they write it as NO2, it means it's bonding with its nitrogen. But if you have ONO, okay, it is still NO2, but it is bonding with its oxygen. So in this case, to name it, it is called nitrito, and this is amine. So we have O-nitrito, and we have sorry, we don't have that. All we have is just amine because we have Na3, so that will be amine. So we see that A comes before the nitrito. Okay, so we name this first. And the name of this compound will be tetraamine. Tetraamine. Then after that, you have named the amine. You now move to O nine. Okay, it's not tetra, it will be penta because we're having 5 of amine. I'm very sorry for that. It will be penta, not tetra. So the name will be penta, sorry, because we're having 5, so that will be penta. Pentaamine, O nitrito. Then you now name your metal. Your name metal will now be cobalt. Cobalt. Okay, then you put it oxidation state, then you have chloride. So the oxidation state of this guy here will be X plus, this one will be 0 times 5. Then NO minus, so it's having just minus 1. So that will be plus, in bracket of minus 1 will give us plus 2 here. So that will be X minus 1 equal to X equal to plus 1. That will be 3. So this cobalt will be in 3 plus oxidation state. So that's the name of that compound. The name of that compound is now pentaamine. Okay, this compound there, it will be pentaamine O nitrito cobalt 3 chloride. So that's how to name it. Now let's look at the third example. So for this third example, we are having this compound, platinum. So this will be just, so this is not an ionic compound. All you just have to do here is that just name them. So you have to name the ligand first before the metal. So we have A and we have C, amine, chloro. So that will be, and we have 2 of that amine, so that will be diamine, tetrachloro, and we have platinum. So platinum. So what will be the oxidation state of this platinum? Because you must put its oxidation states. So X for platinum plus chlorine is minus 1 times 4. Okay, then plus ammonia is neutral times 2, which will be equal to 0 because the overall charge is 0. So X minus 4 plus 0 equals 0. So X will be equal 4. So this will be plus 4 like that. So that will be diamine, tetrachloroplatinum 4. Next we have the fourth one. So we have the fourth one. So let me get rid of this. So we have named this as well. Okay, we have named this. So we are now here. So we have copper and we have this. So this one too is very easy. So you just have to name the ligand and you name the metal. So in this case, we have amine and we have chlorine. So we have just one amine. So that will be amine dichloro. Then copper will be normal copper. It will be copper. Only if this is having maybe 2 minus or minus 1. So if it is having negative charge, that's when you change to corporate. But because it's a natural compound, a natural ligand, a natural complex, you just have to retain its name. So copper, then you calculate its oxidation state. That will be for here it will be X plus 0 because ammonia is neutral, then plus minus 2 because it will be minus 1 times 2 for chlorine equals 0, the overall charge. So at the end we have just X minus 2 equals 0. X will be equal to 2. So that will be copper 2. So amine dichloro copper 2. That is how to name that compound. So now let's move to another one. So the next one is this 5. So to name that one too is not really hard. So just change because it's an ionic compound. So as it is, you would see that we have Cl minus outside the coordination sphere. So it will now become CONH3 5Cl and we have 2Cl minus. So this one will become 2 plus because we're having 2 negative here too. So you name the positive end first. So if you want to name it, you have amine and you have chlorine. So amine comes first. That will be pentaamine. Don't forget your M will be in double M. So then we have chloro because the chloro is a ligand. It's in the coordination sphere. It will be chloro, right? And we have the metal, which is cobalt. So you have to find the oxidation state of this cobalt. So that will be X plus 0 times 5, 0 times 5, then plus minus 1 will be equal to what? Plus 2. So that will be x minus 1 equal to, x will be equal to 3 like that. Then you put chloride. Don't forget, this is having negative, just like sodium chloride. Okay, if you name the positive end, the negative end, so you just call it chloride like that. So this the fifth one is called pentaamine chlorocobalt 3 chloride. Now for the sixth one, here, so that will be, now this, as it is actually 3K plus because it's an ionic compound. So we have 3 of K plus. Then this will now become F. So it will now become 3 minus like that to balance the charge. I hope that's taken. Okay. And if you want to name this, you name the positive end first. So that will just be potassium. Potassium. Then you name the negative end. Now to name the negative end, you have to still name the, it's like cobalt. Okay. Then bonding with 6 fluorine ligand. So you have to name this ligand first before you name the metal. So for this ligand, it is a monodentate ligand and it will be hexafluorocobalt. Don't forget, anytime you are naming your metal, you must put its oxidation state. Now to find the oxidation state, it will be X plus fluorine will be minus 1 times 6 will give us minus 3. So X minus 6 equals minus 3. And X equals 6 minus 3. That's plus 3 as well. So the name of this ligand here will now be, the sixth one here, it will become potassium hexafluorocobalt 3. So that's all. About that one. Then for this one, number 7. Okay, so you just have to name it, very straightforward. So this EN is ethylene diamine. So because it's having di in its name, so you just call it, you don't call it tri, you won't use tri for it, you use twice. So that will be twice. Okay, ethylene diamine. Okay, then Cr is chromium. Don't forget its oxidation state. So together that will be X. For ethylene diamine, it is 0 times 3. Okay, equal plus 3. So that will be X equal 3. Chromium 3. So that's the name for that compound. Now for this, it's a negative complex. So you just have to name the ligand and the metal. Follow, that's all. So for this C2O4, it is an oxalate ion. So this is the way they normally draw it. You just put OO minus, OO minus. Okay, so you call it oxalato. Oxalato. So that's how you name it. Just call it oxalato. Sometimes they will do the structure like this, CC. And I think this is having negative. This is also having the negative. So it's a bidentate ligand. So now to name it, if you want to name this compound, the way you do is that you name this. So it is oxalato and it is having 3. It is 3. So now what you would do is that you just have to put tri in front. Trioxalato. Just try oxalato and you call it ferrite. Instead of you to call it ion, because having negative, it's a negative complex. You now call it ferrite. So you calculate the charge. So that will be X. Okay, and this ferrite, it is we call it a bidentate ligand. So that will mean that it should be C2O4 2 minus. Okay, so if you want to calculate, it means that it will be X then plus. Let me do it here. It will be X then plus C2O4 is minus 2 times 3 will give you minus 2. So X minus 6 will give you minus 2. So X will become 6 minus 2. So that will be trioxalato ferrite 4 like that, because X will become 4. So we have ferrite 4. this is not making sense actually. I think I made a mistake in that question. It should be 3 minus, because iron doesn't normally exist in this form, either 3 or plus 2. So it should be 3 minus. So you just have to change it. See the same step. Okay, it will now become 6 minus 3, and that will be 3. So that will be ferrate 3 like that. So that will be trioxalotoferrate 3. That's all. Now for the penultimate one, let's look at that. So because it's just a neutral ligand, so all you just have to do is to name it's a neutral complex, name the ligand first and the metal, that's all. So this is have chlorine, and this is called triphenylphosphine. Triphenylphosphine. So that will be now, because you're having in its name, you're having triphenylphosphine. You're already having tri, right? So when you want to name it, you don't need to put tri again. It should now be tris. It will be tris. You now put it in brackets, tris, triphen, because we're having 3 of them. So that will be tris, triphenylphosphine. And that's how you name other ones too, like ethylene, diamine, tetraacetic acid. If you have more of that, maybe 2, it shouldn't be di, because it's in the name, it is having di already. Ethylene, diamine. Even it's having tetra. So when you have multiple words like that in their name, you won't use di, tri, tetra for them. You either use bis for 2, okay, you use tris for 3, and you use tetrakis for 4. So that's it. So for this one, it will be triphenylphosphine. Then you name chlorine next as a ligand, chloro. Then you now name rhodium like that. R is rhodium. So I need to be rhodium 1. Triphenylphosphine is 0, so that will be x plus 0, then minus 1 for chlorine equals 0. So x will be plus 1 like that. So then 1. Now the last one is like the one we named here. Okay, the one we named here. Look at them, they are quite similar. But in this case, we're having CO and ammonia as 5. So in this case, oxygen is bonded to that metal, but in this case, it's nitrogen that is bonded to that metal. So that's the only difference. So you just name it like that. So it will now be 5 amine, right? So normally, if you want to do it, it will be CO, NO2 in bracket, don't forget, and we have NH3, 5. Then we have 2 of Cl minus. So you name the positive end first before the negative. So to name this, it will be penta amine, because amine is A. It comes first before nitrito. So it will not be N nitrito. Okay, then you now name the CO, which is the cobalt. Cobalt what? You now calculate. Then you now put what? Chloride. So of course it will still be the same. Cobalt, it will be X. So nitrito is minus 1, I told you, and this one will be plus 0 equal to, okay, 0 times 5 is 0. So this one is minus 1. So plus minus 1, it should be minus 1. X minus 1 equal to, so X will be equal to 2 plus 1. So that will now be what? That will be 3. So this will now be pentaimine N nitrito cobalt 3 chloride. So that's all for this video. Thanks for watching, and please do subscribe to this channel and like the video, like it, subscribe, and make sure you share the video to your friends. Thank you very much for watching.